Well, I'm Rick Atkins. Just a little bit about me. I've been turning almost 2 years now. February will be 2 years since I bought a lathe, a really little tiny marketplace $200 lathe, to see if I liked it, and ends up that I do. So now I do all my turning on a Jet 1221. Because that's what I could afford to buy when I bought it. And then I realized I should have saved another month or so and bought a big lathe. Because that's now where I'm going with some of the stuff I'm doing, because I'm pretty much maxing out the power on that smaller lathe for some of the stuff that I like to do. Segmented turning. I brought a couple pieces. I think that I brought this the first month, year ago when I came in and did this, and I was pretty proud of it. It was actually my second segmented piece. This was my first segmented piece before I even knew what segmenting was. It's just plywood that I cut up into a whole bunch of little pieces, glued them together, and turned a small bowl out of it with a little bit of sapele and walnut thrown in just because I thought it looked cool. But segmented turning, this is when you mention segmented turning, this is the type of structure that you're looking at that most people think of, or like this, where it's a whole bunch of little tiny pieces. Segmented just simply means a bunch of pieces glued together and then turned into something. You know, this is a segmented piece, but it's not the classic segmented that you think that most people think of. Same with this. This one, actually, you can see there's a really nice little piece of epoxy in there because when I made this, I made squares out of the plywood and glued it together. And then after I had it and I started looking at it, and on the inside, you can see there's a little bit of epoxy on the inside too, because I realized that my squares weren't going to be contiguous. And so it's okay, throw some epoxy in it, it works. I was surprised that I only had the one little window, and it came out really cool because it was a perfect little window. But segmenting is a lot of fun, but it's a lot of work doing a piece like this. Or like Captain America shield. They're all done using the same stuff. And what I'm going to be doing tonight is, John, is there a way you can keep the slide on instead of me or whatever? Or is there somewhere that I can have the slide just to me that I can see that? Or a piece of one of my papers, just so I can keep track of where I'm at.
So you want the tower?
Yeah. Or I don't care if you, yeah, I got my paper now. I'll be okay. Just so I don't get lost. So a while ago, Ben had asked me, you know, especially after I brought the disco ball in, asked me about doing a presentation on segmenting or segmented stuff. And I thought about it, like, yeah, sure, I can do it, even though I'm a very new turner. My turning skills are adequate. I am not a good turner, but I'm adequate to get the job done. Sometimes some of my pieces I have to use a little extra sandpaper, but that's okay. In the end, I end up with a piece that I'm happy with. And each piece I do, I learn more with the tools. Like I said, the piece that I'm working on now with using the skew, it's not quite as scary as it used to be. But in the segmented, what I really enjoy about doing the segmented vessels and some of the other pieces that I do is the design and thinking about what I want to end up with when I'm done, what I want it to look like, and just coming up with the design. So what I'm going to talk about is I'm not going to do any turning because no. But design and considerations. You want to go ahead and put it up on the second slide then? Oh, yeah. So all of the pictures in this presentation are not mine. They all came from Google. Okay? Because I take really crappy pictures and they look horrible, but there's a lot of really good artists out there on the internet that have some really awesome pictures of the things that I wanted to show you guys. The considerations and that kind of thing, and design stuff. So I get a lot of inspiration by seeing a picture of something or a video of something and saying, wow, that looks cool. I wonder if I can do something similar. So that's what, and that's also why you'll see me, I'll do for a month or two, I'll do one thing and then I go on to another thing. Segmenting. Actually, the reason I stopped doing the segments is because one of my employees was using my sled to cut something on that I cut my segments with and cut the sled in half, and I haven't built a new sled yet. So he is. He's a good employee.
As long as he's not near your tools.
Yeah. He's like, can you fix it? I'm like, yeah, I got to build a new one. And then crazy life happens. I just haven't made a new sled yet. So design and considerations. Really, this is the heart of it, and this is what makes it successful or less successful in the end. The things to consider is your general shape. You know, the shape of your structure. What's it going to be like? A sphere, a bowl, a vase? What type of shape do you want the thing to have? A theme. You know, do you want to do like a Southwestern, you know, motif, which you can do with your feature rings? Just doing a chevron. This was for the challenge last year for January, which was celebration, I believe. So that's why I made a disco ball, because you can't celebrate without a disco ball in my book, you know. The feature ring design, this is where a lot of thought can go into it, and you can be really super creative. There's a lot of different styles, a lot of different things you can do. They're very simple. Not yet. Go back. We didn't get there yet. Accent rings. That's these little small rings in there. You know, stuff like this, where it breaks it up and just adds character to the piece. This one doesn't have any accent rings. That's just a single feature ring. The wood species, whether you're doing, you know, this is primarily, the bulk of it is cherry with some walnuts, some peely, redwood, or red heart, purple heart. I don't know. I don't even remember what all I used in it. And the number of the segments in the ring. This is something that you're going to need to think about when you're doing it. So those are all just the general considerations. I'll get into each one of those a little bit more going now. So we can go to the next one, which is the feature ring. Your feature rings are going to be the focal point of the design. What you see, the general, you know, in this one with it being a chevron. This one, it has celebration written around the outside and then the stars. So that's what I wanted to do with that. If you know, of course, Captain America, the theme. But feature rings are a lot of fun to design out the feature ring. Okay, and it could also be in an accent ring. You know, the design possibilities are limitless. It's whatever you want to do. Most of them start out as a simple laminate type product. Okay, this was just a couple 60-degree triangles cut and glued into another one. Okay, and then you can take that, slice it down, and now these are really, really awesome craftsmanship on these. Okay, because this morning when I went to put these together, I throw them on my bandsaw, which has a really big blade on it. And, you know, it's like 3 TPI for roughing out big stuff and not really for cutting fine detail stuff. But that was the blade that was on the bandsaw, and I wasn't changing it just to make these things. But taking that simple design like this, slicing it down, and then stacking them back together, you can get all different kinds of combinations, you know, and doing multiple different things with it. With a chevron's very simple to do. It's just, you know, that's the laminate. That's what I glued together. Then I cut it into small pieces on an angle. But what angle did I want to use? And that's where I enlisted the help of my daughter. And I drew it out on some graph paper. And I said, should I have the angle like this? Should I have the angle like this, like this? And she's like, that one. I'm like, okay. And whatever that degrees was is what I decided to cut it on, because that's what my daughter said looked best. I enlist the help of employees, co-workers, my wife, lots of other people, and say, hey, what do you think would look good? I have an idea in my head, help me work through it. I'm indecisive when it comes to some things. I'm still learning to trust my artistic thought process. And, you know, it's fun, but I question myself. I second guess myself on some of it. You know, like general shapes and that kind of thing. And yeah.
One of those segments of that chevron.
Yeah.
That's one piece of wood that you just cut at an angle.
So actually on this one, so that's the laminate. The laminate would be like this, but what I did is, so if you see the little cut marks, if you can imagine each one of those pieces of wood being a different species of wood, okay, you know, that gives you the different color pattern. Then you cut it on an angle, and then so you have that one, you cut it on an angle, and this one's cut on an angle, and then they meet up to make that chevron. Then those two pieces together make up one segment. So that's one piece. And then those, then I trim to the proper angle to make the ring at the end, you know, as I'm putting it together. Yeah, as I'm going through here, if anybody has a question, just ask, because otherwise, that's all right. So, like I said, the craftsmanship on these is very subpar, but it was a 2-minute put together thing. So if you guys want to see whatever. Yeah, just a long length. And then you just cut it into small pieces to.
I think you should put these in a piece and bring it back next month.
I could. I definitely need some epoxy. It's definitely be a resin piece.
What do you glue your segments together with?
Huh?
What do you use to glue those pieces together to make the chevron? Are you using wood glue?
Yeah. Yeah. On the chevron, yeah, I typically, when I'm gluing wood, when I'm using wood, I typically use a Type-On 3, just in case there is some water involved in it sometime, you know, wiping it down, whatever. You know, if it's a utility bowl, not an art piece. So most of my stuff just sits in my shop in the front room because my office staff says, those look really awesome. Put them out in the front room. So I do, and then clients come in and they're like, oh, that's really cool. Okay. But yeah, so what's really important when you're designing out something like this, like I said, is choosing the wood species. And I really found that out big time when I did the stars because I had some really cool color combinations, but I found out that some of those were problematic because of the densities of the woods being dramatically different. And hardwood, softer wood, and so some of it tore out real quick, and some you had to fight through more so. And of course, it could just be because I'm new at turning and don't know how to use my tools properly as much when I was doing these. But yeah, just the feature rings, that's where you can be real super creative. And some of the examples that were shown in the thing there, I mean, if you go on and do a search for feature rings for segmented turning, there's a million different ways of creating a feature ring. Some of them I've done. One I did, it was kind of a triangular hourglass shape, and in the very center I had a resin dot in the very center. And it looked really awesome, but that center dot was actually a design modification because my cutting and gluing wasn't quite perfect. So drill out a hole, put some resin in, looked perfect. And if I didn't tell anybody, they wouldn't know it wasn't part of the original design because it did play in very well with it. So then the next thing is on the next slide would be on the wood species selection. The color of the wood. You know, when you're making something, especially like with your feature rings, the color's the big thing. Also, you know, this is cherry predominantly. This one, I have cherry, butternut, walnut, maple, epoxy, and half a dozen different hardwoods in the stars. Just because, you know, you go to Groff and Groff and you're like, oh, that's pretty. Oh, that's pretty. That's pretty. And before you know it, you have $500 worth of 2x4s. And it's not that many. But that's the problem I go in when I go in there too, is I let the wood speak to me and say, pick me, pick me.
But if you're doing segmented stuff,
right.
All you do is get their cutoffs bin for $75, and you put that in the back of your truck, and then you've got enough cutoffs of different species.
Yeah. You know, it was one of those that I was doing something and I had red heart when I started to do this one. And I thought I had enough to do this. And then I started making the one ring and I'm like, oh, I'm not going to have enough. So I went down and I figured out how much I needed, except I overguesstimated. And yeah, I still have red heart because I overbought. But that's okay. My shop's big enough. I have plenty of space. It'll be there until I find something that I want to use red heart for. And I've used it on quite a few things. But yeah, with the wood species, you do want to be careful that you're selecting them and watching the grain on, you know, down here, because we're doing all face grain stuff mostly, but you want to be between your quarter sawn, your figured, flat sawn, the orientation of your cuts. Because if you have, especially if you're doing this, if you're not paying attention to it and you have a couple different pieces that you've milled out and you have some of it that's oriented flat sawn, some of it's quarter sawn, and they go next to each other, they're going to look terrible. Well, me because the grain is completely different. You know, just watching what your grain looks like, grain selection is pretty important, so that it looks kind of homogeneous. You know, this, I have a lot of smiley faces throughout it and some frowny faces, because the grain's going, you know, sloped the same way in a ring mostly. There's a few of them that I have them not quite oriented right, but for the first attempt at a segmented bowl, I think I did all right on that one. But the densities, again, I found out that aspen is really, really soft. And when you have it next to Purple Heart, it's really difficult to turn it nicely without fighting it. And where I have those combinations, if you run your fingers really gently over it, you can feel the variation between the woods, which is, you know, again, something that I know. So it's just something to be, you know, mindful of, that your grain directions and that kind of thing. So the next thing is the number of segments. Okay. The number of segments in a ring when you're cutting them, the more, it doesn't matter how many segments are in it. You can make however many number of segments in that ring that you want. It's really simple to figure it out, but typically most guys that are doing them are using typically between 8 and 24 segments per ring. You can do 6, you can do 4. This was 4. But what happens, you can see in the picture up here, you can see the outside. There's a lot of flat spot where you get into this one down here, which is, I think, is a 16. And this one, it looks a lot rounder, okay? Which comes into play when you start turning, because the larger number of segments you have, the smoother the turn is, the easier the turning is. You don't have as much air. You're not turning as much air until you get it rounded. So especially if you're going to put the entire vessel together at one shot, the more segments you have, the easier it is to turn without having to worry about it exploding on you, which can happen. I didn't have one explode on me on the lathe yet, but I did in preparation to get it on the lathe. So, which we'll get to in a sec. So, once you determine that, you know, I'm going to use 12 segments, okay. All right, is that the example I have in there? I think so. Yeah. So basically what you do is you just divide 360, there's 360 degrees in a circle, by the number of segments that you want to use. So if I decided I wanted to use 12, that gives me 30 degrees. Yep. So I put it on my table saw and I cut it at 30 degrees. Nope. The 30 degrees is the inclusive angle. That's both sides of the segment. Okay, inclusive angle and cut angle. So the cut angle is half of the inclusive angle. So instead of being 30 degrees, it's 15 degrees. So you would set the table saw up, or your chop saw, or whatever it is that you're using, to cut 15 degrees, and then you'll get 12 pieces that make a circle.
Or a smaller 6-segment piece if you do 30.
Yes. Yes. You'll say, I already have a circle. Whoops. Or almost a circle. So how do I start? Okay. Which would be the next slide. Graph paper. Simplest thing. piece of graph paper. And what I do is, in mine, I set it up. I did this in my CAD program, but you can pull graph paper down off of the internet. One word of warning: when you print it out, make sure you print to scale. Because if you don't print to scale, your grids aren't to scale. And when you start to pull numbers off of it, they're wrong. Because you draw a nice shape, except that shape, and you can't tell when you're looking at it on the printed paper real easily. But what I do is I just have a center line. So like I said, I can do up to a 12-inch turning. Okay, so I just have going out actually 7 inches out from the center. But yeah, so you want to decide how big you're going to make it, what the general shape is. And then the next thing is to go ahead, next slide, is to just sketch it out. Use pencil, because you're going to change it. This is a real quick drawing, just for demonstration. So it's not drawn really nice, although I'm not a good drawer. I get a general idea down on my paper, and then I can work the shape to finish it out. But what you want to do is draw out the shape. So this is kind of an urnish shape. Having my base down here, you can't see. When I scanned this in, I lost all the grid marks. Okay. But you want to also draw the wall thickness that you're looking to have. Okay, this is approximately a 1/2 inch wall thickness on this drawing. All right, so you draw the general shape, and then with the graph paper, if you decide that each one of your segments, the height of your segment is going to be 3/4 of an inch, you just count up 3 blocks. In my case, because it's 1/4 inch grids, just measure up 3 lines, draw a line through where it crosses the outside and the inside of that segment. So this is the segment in here. Okay, so when I'm doing it, I go through there and I figure out where my feature ring is, if I'm going to put accent rings in, whatever it is that I want to do, and be creative with it. And that's where it's going to change, because you decide I want to have a feature ring in here, and I want to have it right at that spot. But if I'm marking this up and I see that it's not going to match up to my 3/4 inch, I may need to modify where my curves are going so that I can redesign the height element to it. But then what I do is over on the side is, this is, and I number them going up through. So ring number 1, it's 3/4 of an inch high. Okay. It has a 2-inch radius. So what I'm doing is I'm going to the outside, the farthest outside of it, and that's a 2-inch radius, and it's 1 inch coming across here. So from the inside corner to the farthest outside corner.
So why do you need a 2-inch radius? Couldn't you have a 1.5 inch radius or 1?
Well, no, because 1.5 is right there. If I had a 1.5 inch radius, it's absolutely from the center line.
But the piece's radius itself is only 1 inch.
That's 1 inch. Okay. Yeah. So the width, and this is where it gets weird, because when you start looking up anything to do with segmented turning, and those of us have worked in carpentry, they use the terms wrong. Okay. Their height, okay, and thickness, and I have that marked down here, and when I get to it, I'll read it, because I always want to screw it up. Okay. But then I just go each ring. So this one, you can see that one, it's a 3.5 inch radius with a 2 1/4 inch. So I'm measuring from here to here. That gives me 2 1/4. So that's my minimum sizes. Okay, if everything goes perfect, which is why this is not quite a complete sphere.
Didn't have enough epoxy to make
I didn't give quite enough wiggle room.
Do you have a recommendation on how much wiggle?
Give yourself a little more on both sides. It doesn't have to be a whole lot.
A little more being a 1/4 inch?
Quarter inch on either side is going to give you plenty. The other thing is when we start looking at the radius and start talking about it, that radius is to the flats, not to the actual outside of what this is, which is, sorry, the ring diameter actually is to the outside points when you're doing this, when you start to get into the cutting. Okay, it's not the flats. But when you shave those down and you get down to the flats, that's where you come up a little bit short.
So you want to measure your diameter to the flats. So
correct. So you're giving it just a little bit extra. Okay. And it's not so bad until you're doing something like this where I figured it out and I said, yeah, 3/4 inch will be plenty to get my rings. But what I didn't account for was the diameter of the finished ring compared and the width of the segments. So I got some flat spots on the inside. The rest of the rings I shaped. Yeah.
So when you say you have a 3.5 inch radius
Right.
dimension,
Yeah.
that's to the center of your segment?
No, that's going to be to the outside. So when you want to pull the drawing up again? Okay. So, nope, yep, that one. So the 3.5 is out here. That's going to be my finished edge. Okay.
Finished edge at the middle of the piece or the corner?
It's going to be at the middle of the piece.
Okay.
So I need to add a little bit onto the outside of that to take away to get back to it.
So you're going to turn the corners away.
Right. So, and on a small diameter ring like this, that's a 32nd to a 16th of an inch. When you get into a 12-inch diameter, that can be a 1/4 inch difference between the points and the flat when you get the radius turned. What's that?
I believe they call that dimension from the flat to the curve of the middle ordinate. Is the dimension
Okay.
between the two. And I've got the tea and the biscuit, you're good to go.
Yeah.
So Rick, when you start those, before you put them on the lathe, are they cylinders or rectangles?
No. They'll look like this. Okay.
Stacked up?
Yeah. And so you have just a whole bunch of little pieces that are glued together. You make it into the ring. So this ring would be the very bottom.
Right.
So this is a test ring, and it doesn't matter. I have no idea what the diameter is on this. This is just one that I did a test on, just setting it up.
So before you put that disco ball on the lathe, it was a cylinder or a rectangle?
No. It was
Oh,
it was
the
this.
shape already. Ah,
Okay.
yeah, right.
So
Okay, yeah.
this
Ah, okay.
is that,
So you're just knocking off edges. Yeah.
and then
Okay.
we have that one, and then a little bit bigger on top
Now I get it.
as you go up
Okay,
to develop it. So, I mean, you can see, they're different size. These two are different sizes.
And that's why you use a direct move.
Yeah. So that way you can develop what you need to figure out what you need to cut.
And then those eccentric rings, as they work their way up on that sheet, they're glued together. pressed,
Yeah.
And then once
Yeah.
all that's dry, then you go and turn.
There's a couple different ways of doing it, but yes. So yes, and maybe not.
So do you glue those up together on the lid, or do you?
I'll get to that shortly. So once you get all that stuff figured out as to for each ring, okay, you want to pull that sheet up again? Okay, once we have all of this stuff, that's the raw data that we need in order to come up with a cut list. Next slide. Okay, so on the internet, there's a lot of charts and stuff that give you a lot of this stuff. You know, as far as the angles, the number of segments, and so on that, it gives you that stuff. What I did is I just extrapolated all that stuff, put it into Excel for myself, so it made it real simple for me. That the number of segments in a ring, this gives me the length factor, a saw stop, an angle, a bottom and top fence setting. So that gives me all the information I need in order to cut my stock. Okay, the length factor. So this is just giving you rough stuff, and once you figure out, okay, well, I need 26 segments, or well, 24 segments. Okay, in the 12. So that gives me information. And this is just a snapshot of raw data that goes into another formula that figures all this stuff out for me. But this up here gives you that data that for, well, we got a 7-inch ring with 8 segments. Each segment is 2 7/8 of an inch that you need times the number of segments. So you would need about 50 inches to do that size ring for that many segments. Board length, yeah. Not board foot, but board length. Okay. So next sheet, next slide. Okay. This is my disco ball. This is out of my spreadsheet. This is the program that I wrote up to figure all this stuff out for me. So all I did is there's 11 rings in that disco ball. So each ring, and then, you know, the number of segments, I had 16. The feature ring was 18. Everything else was 16 segments. The different radiuses, the diameters, the wood species that I was using, although on the disco ball, each ring was multiple species, so it didn't really matter. But then I also have up above that, so this is giving me all that stuff, but it tells me the angle that I need to cut, you know, 11 1/4 inch cut angle for those. And it gives me the cut length. So for that first ring, it's 1.49 inches is what I need to cut that to end up with the size, the diameter ring that I want, which is where calipers come into play for setting up doing the cuts. Just using a simple caliper. It's really easy. You don't want to use a tape measure. Tape measure doesn't measure accurate enough when you're getting to that kind of thing. But then what I did is out of this is I extrapolated out so I have the cut length, I have the height, okay? So when we think height, we think linear height, or, you know, from the ground up height, but it's not really. The height on this, you pull that back up, okay? So, the height is this way, is the thickness of the rings. Okay, those of us that are in carpentry think of the thickness coming this way. Okay, the height, or come back, the thickness is coming to the center, how wide the board is. You know, at least that's the way I look. When I look at a board, if I have a board laying down in front of me, you know, this is the thickness. or this is the height, and it's just confusing. So, but once you understand that, so this is going to tell me that the stock length that I need for this first ring is 25.87 inches. So how much stock do I need for that? 36 inches.
With the saw curve or without the saw curve?
Well, that's incorporating the curve into it. So if I cut a piece 25 7/8, I would be able to get my ring. Probably. But just add a little bit to it. And then what I did on this to make it easier for me is I have it by my height and my thicknesses in these boxes out around here. And that tells me, you know, for the cherry, 3/4 inch height by 1 3/4 depth, I needed 65 inches. For 1.5 inches, I needed 34. 1 1/4 inch, I needed 35. So, because I told it was 1/8 of an inch. It's in the formula. It's not on this page. It's a sheet behind the sheet that has all that stuff in it. So it incorporates from that other table the length factors. Okay, it's just math, but it's all hidden. I just kept it simple here. So it just spits out the information I needed to know. I didn't need to know that because when I wrote up the program, I added 1/8 of an inch to the actual length needed because that's being depleted apart each time I cut, because my saw blade on my table saw is approximately 1/8 of an inch. So, but whatever it tells me, I cut extra. So, so that gets to, once you know about how much wood you need, then it's time to start actually, you know, getting off the computer and playing with wood and becoming a woodworker, which gets us to the milling. So the milling is the most critical when it comes to this. So you want to make sure that you have enough stock to cut each ring. Okay. I know that I need enough material that if I'm doing 3/4 inch stuff, I'm milling a whole lot of 3/4 inch stuff. If I'm doing 2 different boards, you know, a cherry and a walnut, and they're going to be intermixed like this, when I'm running them through the planer, I run all my boards through at the same time. So when I finish out, all of my boards are exactly the same thickness when I'm done. Because if I pick up all my cherry and I run all my cherry through, and then I start with, because if you go to the lumber yard and you get 4/4 lumber, they're not all exactly the same. Even if it's 4S4, they're not all exactly the same. You know, some are going to be coming in a couple hundred thousandths bigger or smaller than the other ones. And if you're just nailing a couple boards on the wall, you're not going to notice it. But when you're trying to put stuff together, you notice it. When you're cutting it down into the smaller pieces, especially if you get into some of the really ornate, fancy segmented stuff where they have flower designs and all of that, and they're using 16 different woods. Yeah.
Can I ask you about design just for a second?
Sure.
So the way you're talking now, you're talking about 3/4 of an inch height, right?
Right.
For all of your rings. So the question is twofold. Do you mix up the segment numbers in your rings, and do you mix up, with the exception of your accent rings?
Right.
Do you mix up? Have you done successfully mixed heights, the thicknesses of the ring?
Yeah, not within the same ring.
Well, obviously.
Although you can.
A lot of epoxy.
Well, yes, you'd need a lot of epoxy, or you'd have to be very, very precise, but then that goes back against some of the general technique, which when we go to stacking them, you typically do a stack mason, brick stack, where you're offsetting it. So if I wanted to use two different heights, I could, but it'd be very, like making what is it, a Lovejoy connection, where you need to, they fit together like this, and I'm not that good.
Same ring. I meant,
Yeah.
just for your eye. If
Right.
the rings are not all the same height, is that pleasing or displeasing? And if they're not the same number of rings, because say you want to so let's say you have a color that you want to particularly not chop up into little segments.
Right. So it looks more uniform.
4 rings instead of 12 or
Right.
whatever, right?
So yeah, you can. You can do whatever you want with the design.
Have you found that
Mine, I've kept mine similar. I've done them with 12 and 16 and 16 and 18 because they're just 12 to 18 are very nice rings to work with, is what I found. Smaller than 12, it gets real bumpy. More than 18, it's a lot of excess cutting and gluing and manipulating.
I need to help Thomas's answer. I find that your ring height, for me, should correspond to the slope angle of the. In other words, if you got
Right. So
a shallow or an angle like this,
no, I don't have one.
so that they have the same appearance
Yeah.
on the outside.
So these are all 3/4 of an inch. This one looks bigger than that one, which looks bigger than that one, and that one, and that one. So
you can graduate them if you want even spacing, or you can
yes,
space them even
if you wanted each one of the sections to look the same, you would have to vary the height. It would, but it wouldn't be that hard to figure out because it's based on math. But
You can also do it graphically on your little chart there.
right, doing it on the chart, you can do it on the graph paper, you can do it and you can see it somewhat. Some people can see it, some people can't. Some people, I have that half profile drawing and they're like, this is what it is. Oh, okay. No, that's not. So, but yeah, so there's a lot of different things that you can do with it.
So, and obviously this works only if you try to replicate the same shape and mold. But similar to those little rings that you created, say for example, I wanted to make a 16 piece
Mm-hmm.
high each 3/4.
Right.
Could I take a piece of wood, lay it down to 3/4, get a compass, draw an outside circle, draw an inside circle for the thickness you want, cut those in those circles, and then I appreciate all that math. Put it on the saw and go chop, chop, chop into
Like a
whatever
pizza.
angles you want.
Like a
Glue it
pizza
together.
Yeah.
and then
That's this type of thing.
Yeah, then you
Now it's different than this
Okay.
because this was just blocked.
All right.
This was just blocks that I cut together and glued together and turned it. And it got some interesting things.
That way, I mean,
But yes,
in my mind,
so
segmented.
to do what you're talking about, you could do something similar to this.
Right.
Okay. Now this is exactly like this, just turned a little bit differently. And the way it was put together, because I turned the center, then I turned the inside diameter to match the outside diameter of that, and then I got that put together, then I turned the inside to match the outside and progressed out. So this was done piece by ring by ring is the way I did the assembly on this one. And you can, and there's something similar, which is a board, bowl from a board method, which is similar to what you're talking about, where it's out of a single piece of wood. Okay, so yes, but no, when it comes to this kind of thing. But yeah, you can do, you know, once you, it would not look segmented. It would just look stacked.
If you make those circles into molds, or templates, if you want to call
Right.
it, and then you cut the little piece of the segments, whichever 8, 16, however many you want, you can take a piece of cherry, put it in that hole, put a piece of
Well, yeah.
walnut in that
So it's a lot easier doing it the way I'm going to get to doing it here very quickly. The,
In the interest of time, when you get to your sled,
yes, I'm getting there. So
The engineer wants you to get to the sled.
once you get everything milled,
Information.
once you get to the milling, get all your material milled, then it's time to cut. Okay, so then you go to the cutting, and then you have the different things for doing the cuts. Okay, this is the most common, most popular way of doing it, and I don't like it, but that's me. This is what's referred to as a wedge sled. Okay, because you use, now of course I didn't buy wedges, I made them, and my angles aren't quite right, but I like using the single fence cutter sled better myself because I like it better. But this, what you do is you slide this in there, and this isn't, adjust it. Well, once I get it adjusted right, down in against the sled, okay, and tighten that up. This goes on the table saw, and you just stick your board in there, your piece of material, you stick it through, run it through, bring it to the bottom, run it through, it's going to give you your wedge. Okay, this is going to cut that angle, and when you bring it down here, it's going to cut that side angle, where my hand might be going backwards. You don't have to flip the piece using this. Now you can also go from here to there, and it's going to achieve the same thing, but sometimes you have to flip them. And my single fence, so this goes in, has the runner to go in the miter slot on the table saw. Then what's critical is all the pieces have to be the same length across that front face of the wedge. Okay, so this is a stop block that I have set up for on my table saw. This goes into the miter slot on the opposite side of the sled, goes in here. The blade is right along the edge. It runs, it's a zero clearance, okay? Which then you make something like that to go on the blade, on the opposite side of the blade, so that it sandwiches the blade. I don't know if you guys can see that or not, but there's a little small, there's a blade kerf there.
Turn it toward the camera.
Oop.
Just turn it forward, yeah.
Can you see there?
Yeah,
In between here, there's the blade sits in there, so the sled runs. And what this does, this is a sharp angle here. So once the piece gets cut, it falls away from the blade. Otherwise, sometimes if you don't have that, the little piece can get tangled up in the blade as it's spinning around, and then fly it somewhere, cut it up, damage the piece that you're cutting.
and hit you in the face.
It can do that too. So that's where this comes in. Okay, this gauge right in here, this is adjustable. So what I do is I set this right up to the edge of the tooth of my blade, not the flat side of the blade, but to the tooth of the blade. The reason being, this is the outside edge of that tooth where it's doing the cutting. Because the carbide sticks out a little bit outside of the blade. So if you set this, and so I can zero that out to the outside of my blade, to the outside of my cut. Then this distance in here, my caliper, I can say, okay, I need whatever that is and set it to that depth and then adjust this depth. So let's just say my segment needs to be that long. Okay, all I do is set it in there, whoop, until I get that. Right, like that, tighten it down, and then my cuts are all going to be exactly whatever I set it to be. So it's real simple. You can do it on a miter saw. There's guys that do it on that. My miter saw is not that accurate. I'm not going to try to do it. My really old table saw has some issues sometimes with the blade tilt. Sometimes it likes to drift a little bit, but you can't see it. So you want to make sure that you're setting the blade square to the table. Because one of these, I think it's this one, on this side I have really nice tight joints. On this side I don't, because my blade was about half a degree off 90. So you will pick that up, you will see it. But what you want to do is after you're done milling, you want to make sure that you mill some scrap wood, some junk pine, just so that when you're setting this up, you use your scrap stuff, the stuff that costs you 50 cents a board foot, you know, real cheap crap, and do a test ring. So you run, I'm doing a 12 cut, I cut my 12 pieces, put them into a ring, look at them, I'm like, yeah, it looks great. Oh, crap. Nope, it's not. So I can make that adjustment, and then I can get a nice ring. This one's not quite right, but I figured out that it wasn't just this, but my angle was off a little bit. So when you do these, because I used that because I didn't have my good sled to make my pieces, and I didn't feel like screwing around with it. What you can do is you can just, when you're doing your glue ups, is just glue half of the ring and glue the other half of the ring in one piece. Don't try, you don't glue the whole thing if you have a little bit there. Otherwise, I mean, I can go back, I can make the adjustments and I can get that out so that it's a perfect fit, because I know that I need to, well, I already moved the fence, but I need to move the fence one way or the other in order to get rid of the inside section, because I have a gap at the outside, so I need to remove a little bit of wood on the inside. So just by closing up the angle a little tiny bit, and it doesn't have to be a whole lot. And when I say not a whole lot, when I was on my sled, I had 425 millimeter from pivot point to secure point. If I needed to close up that much, we're only talking about 100 thousandths that you have to move the fence to clean that up in a 12 ring. And it depends.
If you had enough play on the outside of the ring, you could just bring the rings together, couldn't you? Or no, your gap was on the outside, not on the inside.
Right.
Yeah.
If the gap's on the, well, see, so this is where then you would do the half ring glue up, and then running from that. So, you know, the other thing that plays a big part is digital angle finder for setting up. That works real well. Once you get these guys done, where am I at here? Miter gauge, yeah. Geez, angle finders, all right, yep. Once you get the angle set, cut all of your 12 segment pieces. If you're doing 12 segment, you know, if I'm doing 12 and then I want 16 and I want 18 and I want 37, you can do that. But cut all of the same number of segments all at once. Doesn't matter the thickness, how wide these pieces are. The angle is going to be the same. And the angle is what's important. It's not how wide this is up here or how, you know, long this is in here. It's the angle. Once you get the angle, if I'm doing 12s, cut all of my 12s. Then move to your 16, set up the angle for the 16, cut all of the 16s. And when you're cutting them, cut a piece or two extra, because there can be chip out or something, or you get it cut and you're like, oh God, it's got a little piece of a whatever. And you can throw that piece out and you have a spare piece. So, any questions on the cutting stuff? I mean, it's...
You talked about gluing up a half a circle. How do you do
right.
that?
So, what you do is you put them together, okay? But you only put glue on these, and you leave a space. And typically what you'll do is put a little piece of dowel in between the two halves. When you clamp it together, the dowel will take up the misalignment of the joint. Yeah, just a little 1/4-inch dowel rod. Just put it, or pencil, just something round. Well, a little bigger than a skewer, about an 1/8 to 1/4 inch, and that'll allow that you'll get the even pressure on the two half rings. So
you always clamp up rings, because a lot of people just dry rub with glue.
I dry rub and then I clamp them, and I let them go overnight, unless I'm in a really big hurry. Never seem to be in a big hurry except for when I screw something up and have to make it hurry. But I try to let them go overnight, because then typically if I have to make a new ring, I'm going through that whole process again. So I try to slow down when I'm doing it. So if you're going to do that, this is a jig that I made up for my lathe. Okay, this is my disc sander. Okay, it goes on. This slides down into my tool banjo. Yeah, that's it. All right, and this slides up against it. I'm not sure which way. I think this way. So I have a nice square table to the disc. So that way, if I'm doing half discs or half rings, I can lay that flat on here and come up against it. The other thing this is great for is once you get these things glued together and you want to do it on a flat surface, I have a little piece of marble, so it's a nice flat surface. That what I do is I put a little bit of glue. Remember, it's end grain gluing. And depending on the species, some woods go and suck the glue right out or off the surface. So a lot of times, like walnut will do it. It'll suck it right in. Cedar, forget it. You can't keep glue on the outside. But what you do is you slap some glue on it, let it sit for 5 minutes, and then come back and put more glue on. And then the glue will stay out at the surface where you need to make the bond. Put it together. Clamp it lightly. Don't crank it down. Just lightly clamp it. Get it in, wiggle it around, make sure that everything looks good. Everything looks good. Flatten it out, and then let it sit for about 5-10 minutes, and then come back and put a little more on the tension. By doing that slowly, you get a better, more thorough joint connection than if you try to just squish it all at once, because the glue will squeeze out.
would recommend putting glue on all, if you have an 18-piece circle, putting glue on all 36 faces before you put them in contact.
Yeah. Yeah.
It adheres itself so quickly by, like you say, sucking in the end grain.
Right.
Next thing you're breaking joints open to try to get them back aligned.
Yep. So the other thing is these guys, no matter how great a job you think you did, they're not going to be perfectly flat. And remember, you're going to be joining this surface to this surface to stack them. So those two surfaces need to be perfectly flat to get a good joint. So that requires another couple tools. Disc sander works great. Just take it and I can get a flat side. So now I need the second flat side, right? So I just flip it around and do that. Well, it's going to be flat, but it's not going to be parallel. So this is where a thickness sander comes into play. All right. And I know everybody in the room here has an extra $3,000 sitting around to get a thickness sander that you're going to use, like 3 times. I know I do. Okay. You can. But if you run it through a planer, there's a really good chance it could explode on you. Because a planer is to go over a single direction and not end grain. Okay? If you, here, pass that one around. If you look at it, in between each segment, you end up with a little bit of end grain sticking. And especially if you're using a carbide, a spiral bit, it'll catch that, and I have no idea how I know that.
You didn't put it through with metal ring still on it, did you?
Absolutely not. Even when I had it glued down to something, because I thought that would be a good idea. It was not a good idea. It exploded, and then I had to sharpen all my carbide tips in the planer, which takes a long time when you count up how many little chips are on them spirals. But most of us can probably take about an hour and make a thickness planer. Okay. Huh? Thickness sander, sorry. Yes. Okay. So all it is a smooth drum, rolling pin. Okay. One of the first things just get something round. Okay, we got something round. And then you just affix some sandpaper to it, spiral it around, and then that's what this is. And this is set up for my little jet lathe. Okay, this sits in on the bedways. This locks in between. And I just have a little thumb screw over here that I can, a quarter turn, run it through. Quarter turn, or quarter turn up, whichever way I need to go. Okay, to bring it closer. And that's going to slide this. This slides, feed it in from the top at the back of the lathe. Okay, so this is spinning this way. Okay, so when I feed it down this way, it planes that surface. It sands that surface, and it keeps it parallel to this. So by hitting it with the disc sander and getting a flat surface, just like when you're milling other woods and you use the joiner to get a flat side, and then you can run it, it's the same thing. So you can get a parallel side to that side that you flattened on the disc sander. And there's no flex in this. Very, very little.
So you're not getting it.
Right, now, so then you just feed it through, and again, same thing. I run all all my glued up rings all at the same time, so I don't have to keep adjusting this for each ring. And then they're all the same thickness. So all of my rings are going to be the same thickness. Does it have to be that way? No. That's if I'm going to, go ahead, give me the next slide. Okay, that's gluing. Next one. Thickness sander, okay. Next one. Okay, so these are the different ways of putting it together. Okay, you have these presses, okay, which you can set it up where it has a rod going up through, and then you wing nut it down and it squishes it down. You can do it just setting a weight on top of it after you glue them up. You can do it on the lathe, and it depends. So doing the disco ball and doing Captain America, I did those on the lathe. And what I did is I glued together like 2 layers, okay, initially, and got those rounded out, and then I faced the top ring. Well, I have one flat face on this just with the disc sander. So that flat face will go on the face that I surfaced on the lathe. So they'll mate up nicely. And then I can face this with on the lathe and put the next ring on top. So it depends on what you're doing. And especially if you're doing kind of the shape that I had drawn out where it's doing this, you may want to do that in a couple different pieces because it's going to be easier. Because doing the inside it's different than hollowing. Because on hollowing, you're expanding out, but you have all that air that you're turning with the segments until you get it smooth. So doing them in pieces and sections, it makes it a little easier. Any questions on that stuff? Okay. So the assembly, when you're putting them together, you want to stagger the joints so that they're not all together. So that way you have less likelihood of them exploding on you. And giving the glue adequate time to dry, if not cure, before putting pressure on them. Turning them, light cuts. You know, you can't go in and try to hog it because it'll probably explode. Keeping the tools real sharp, very, very important, as it is with all turning. And typically I'll use a pull cut versus a push cut when I'm doing the segments, at least until I get to maybe, the last cut or two, and it depends on the angle that I'm facing. If I'm going away from myself, if I can go that way, I go that way. Otherwise, I just use a pull cut. Either way are fine, and then ended up with a shear cut, shear scrape, whatever you want to call them. And so, like I was saying, the inside, you can see how rough it is. So that's why once you start curving back inside, it's a lot easier to do if you just do a ring or two at a time, and then you can just get a little shape. So you don't have to reach way inside and end up with a big catch. Or doing it in 2 pieces and then just glue them together and finish them. Kind of like what, with the disco ball, of course, except I didn't glue it together because I needed to be able to access to get the lights. But it's the same kind of thing. Getting it together, if I wanted it to be a solid sphere, I would have glued it, but then I couldn't have finished it. Any other questions you guys may have?
No, I'll bring you up the bottom.
It's one of those that they're a lot of fun. The finishing, it's finish however you like to finish things. It's, you know, follow that procedure. You know, sand through the grits and use the appropriate finish for what you're trying to accomplish. From gloss to matte to whatever.
When you're sanding, do you have trouble with the dark wood bleeding into the light colored woods?
Occasionally, especially like red heart into like a soft maple.
What can you do about that?
Um,
Anything?
keep the sandpaper fresh and do not use acetone to wipe it down.
Can you use sanding sealer at first?
Sanding sealer would help with that also, because you're sealing it up, so you'll have less of a bleed issue. But yeah, you don't want to use denatured alcohol or acetone to wipe down red heart or purple heart, especially if you have it on a piece of really beautiful white maple, because then it turns it purple. Unless you want purple, because that's what happens. Yeah. So, but yeah, there's, you know, it's a lot of fun. This is a subject that you can go down a really big rabbit hole and be there for a long time. And I hope this answered a little bit of questions or raised a few more. But so something like this, I probably had 50 hours and just making the sphere and just the glue up. The turning took an hour, but the cutting and everything, and then with the epoxies. So if you're using epoxy, you want to use an epoxy glue because wood glue will not hold it.
Thank you.